Chapter 7, Section 2. This is integration by substitution. Or you could say anti-differentiation by substitution. Page 342, exercise 18. The integral of x cosine 2x squared dx. So we start this problem by first changing the order of what's here. We're going to rewrite the integral of cosine 2x squared x dx. Just put this x over here. And over to the side, we write let u equal something. We're going to write let u equal 2x squared. This actually is in the directions. If u equals 2x squared, then the derivative of u with respect to x is 4x. Multiply both sides of this by dx. Du equals 4x dx. Multiply both sides by dx. Integration by substitution is what I call integration by magic chalk. Because when I started doing calculus, we had something that we called chalk and chalkboards. It works like this. We look at what I'm underlining here, and we look at what's over here, du equals. We say, we wish this said what this says. We wish this said 4x dx. So you get a piece of magic chalk, like a magic wand. You wave it over this 3 times. I wish this said 4x dx. I wish this said 4x dx. I wish this said 4x dx. And magically, it does. Magic chalk. Well, it's not really magic. We are allowed to put this 4 here. That means multiply by 4, as long as we also multiply by 1/4, because 4 times 1/4 is 1. So we can say the original is equal to this because it's the original times 4 times 1/4. 4 times 1/4 is 1. Multiplied by 1 doesn't change anything. So then we copy down the 1/4. We copy this symbol, COS, we copy that. Where it says 2x squared, right here, we write u there. And the 4x dx, this entire expression, 4x dx, is du. I used yellow, so I'm going to rewrite it. 4x dx equals du over here, yellow. So just to make this totally clear, I'm going to rewrite what I have there. 1/4 integral cosine u du. And according to the 5th formula on the new sheet you received, the integral of cosine u du is sine u plus c. This is obtained from your formula sheet. Integral of cosine u du is sine u plus c. That 1/4 in front just gets brought down. The final answer is 1/4 sine 2x squared plus c. Now we're going to check this answer, that I want to repeat that this is the answer. So here's a check. We just got the answer, 1/4 sine 2x squared plus c. To check this answer, we find the derivative of the answer. And we do that by bringing down this constant 1/4. And we know, hopefully we know, the derivative of the sine of 2x squared is the cosine of 2x squared times the derivative of what's in the parentheses. 2x squared is in the parentheses. The derivative of 2x squared is 4x. This is here because of the chain rule for finding derivatives. Derivative of any constant is 0. So the answer that we got is here. The derivative of that is 1/4 times 4 times x, which is just x, times the cosine of 2x squared, plus nothing. Since this is the original integrand, look back here, x cosine 2x squared, that's that. That means this was the correct answer. Next one is number 36. Integral, or antiderivative, of dx over sine squared 3x. That's exactly the same as the integral of 1 over sine squared 3x. dx. 1 times dx is dx. Exactly the same as the integral of cosecant squared 3x dx. 1 over sine squared is the same as cosecant squared. Now we let u equal something. I'm going to let u equal 3x. Much discussion is needed about this step right here, but right now just take this, accept this, let u equal 3x. The derivative of u with respect to x is 3. That means du equals 3 times dx. So you get out your magic chalk, your magic wand, because over here you are going to wish that this says this. This says 3, this says dx, we wish it said 3 dx. So abracadabra. There, it says 3 dx now. Magic. It is not really magic. We're allowed to multiply what we have by 3 as long as we also multiply by 1 over 3. We have 1 over 3, the integral, cosecant squared 3x, that becomes u right here. 3 dx right here, that's du. It says it right here. 3 dx equals du. 3 dx equals du. 3x equals u. And the 1/3 comes down. This integral is exactly formula 7, the 7th formula on your sheet. The integral of cosecant squared u du is negative cotangent u. Plus c. So our final answer, positive times negative, so we say negative 1/3 cotangent 3x, the u turns back into 3x, plus c. So the strategy works like this. When we have something to integrate or find the antiderivative of, we let u equal something so that du, or u equals something that's here, du, whatever u is the du, and that has to also be something that's there, except a constant multiple can be missing. In this case, 3 is missing, so we can just make it appear. So u has to be something that's here. Du has to also be there, except a number can be missing, a number multiplied. And this is the most important when the substitutions are made, we have to have an integral that is on the formula sheet. So if we do some substitution and we get an integral that is not on the list, in your list of total integrals, integration formula, then you should start over, try to let u equal something else. And the one we already did, this one, we let u equal 2x squared. The book actually told us to do that, but 2x squared is there. And du is also there, except the 4 was missing. So, and we ended up with the integral cosine u du, which is on the integration formula sheet. We'll try to say all of those things again when we do number 38. The integral of 6 cosine t over parentheses 2 plus the sine of t squared dt. So I'll rewrite this with the 6 that's multiplied to the left of the integral sign. All this in the denominator I'm going to write as 2 plus sine t in parentheses to the negative 2 with cosine t dt all next to that. This exponent is now negative because it's not in the denominator anymore. Cosine t dt is still there. The 6 that's here is to the left, as usual. So now we let u equal something. There's a lot of possibilities here. U has to equal something that's here. When you're first doing these and you've never done this before, it will be difficult to decide what to let u equal. If we let u equal what's in the parentheses, 2 plus sine t, derivative of u with respect to t is going to be cosine t, because the derivative of this is 0 plus cosine t. That means du equals cosine t dt, which is what so I'm going to say I wish this were over here, and it is. I don't even need to use magic chalk to make a number up here. Cosine d dt is what I wish was here, and it's here. So I copy the 6, I copy the integral symbol, I replace what's in the parentheses with u, I copy this exponent, negative 2, I replace what's underlined in purple with du, right there, and now I have a formula that's on the sheet. If I was here and this was not a formula, if there was not a formula for this, I would start over, I would let u equal something different. But this is good. Bring down the 6. According to formula number 1 on the sheet, the new sheet you have, the integral of u to a number, du, is u to this number plus 1 over this number plus 1 plus c. And a simpler way to write what we just wrote is that's a 6 over negative 1, so it would be negative 6 over u, because u to the negative 1, I can make it u to the first if I write it in the denominator. And so the final answer is negative 6 over 2 plus sine t plus c. That's it. Negative 6 over 2 plus sine t plus c, because that's u is equal to this over here. All right, now let's check out number 54. This is a definite integral. The integral of r times the square root of 1 minus r squared dr from 0 to 1. I'm going to rearrange or rewrite this as the integral of parentheses 1 minus r squared to the 1/2. The r that was at the beginning I'm going to put over here. You might have a temptation to put this r to the left, but the only thing you're allowed to take to the left is a constant that's multiplied. This r has to stay to the right of the integral sign. So we have to think of something to let u equal. If you're all on your own, never did this before, you might go through a little bit of trial and error. But we don't have time to show all that, so we're going to just let u equal 1 minus r squared. That's something there. The derivative of u with respect to r is 0 minus 2r. So du equals negative 2r dr. Negative 2r times dr. In practice and with experience, you, I'm hoping, will be able to not write this step down. Just go immediately to u equals something to du equals something with the dr attached. So don't you wish this over here said negative 2r dr? I wish it did. I wish this said negative 2r dr. Well, abracadabra. It does. The reciprocal of negative 2 is negative 1/2. So you are allowed to make a number up here, any number you want, as long as you also put in the reciprocal of that number out here. Negative 1/2 times negative 2 is positive 1. So negative 1/2, the integral of u to the 1/2 du. Because the stuff in the parentheses right here is u, the exponent is 1/2, and the stuff in the green parentheses, is du. And once again, we have the first formula on the sheet of formulas, because the negative 1/2 comes down. The integral of u to a number du is u to this number plus 1 over 3/2. And there's no plus c in this problem because it is a definite integral, 0 to 1. So, a couple things to do before we plug in the numbers. I'm going to change the dividing by 3/2 to multiplying by 2/3. And we're also going to turn u back into 1 minus r squared. This u right here is really 1 minus r squared. Not needing the plus c with a definite integral. You could use plus c, but then it would cancel later. Right, so this negative 1/2 times 2/3 is negative 1/3. 2's cancel. 1 minus r squared to the 3/2. And we have a bracket, and the integral is from 0 to 1. That means we replace all the r's with 1. Minus. And then after the minus, we replace all the r's with zeros. 0. After the minus, it's negative 1/3 times 1 minus 0 squared to the 3/2. So be careful with this arithmetic. It's negative 1/3. In the parentheses is 1 minus 1, which is 0, and 0 raised to any exponent is going to be 0. But these two minuses here make a plus 1/3. 1 minus 0 is 1. 1 to the 3/2 is going to be 1. So this term at the beginning is 0. 0 times anything is 0. The term at this other term is positive 1/3, making the final answer 1/3. You can check this with a calculator using the Math 9. Number 62. The integral of dx over 2x minus 3. Integration from 2 to 5. Rewrite as the integral of 1 over 2x minus 3. dx. There's a 1 understood here, from 2 to 5. We're going to let u equal something. I think I'm going to try let u equal 2x minus 3. du, the derivative of this is going to be 2. I'm going to stick a dx here. Skip this step. Don't we wish this said this? That's what we wish. It says dx, we wish it said 2 dx. Abracadabra. We can write that 2 there as long as we also put a 1/2 in. We now have 1/2 of the integral 1 over, what does 2x minus 3 equal? What does 2 dx equal? And this is a formula on the sheet. If it weren't, we'd start over. So we got a 1/2. And according to the second formula, the integral of 1 over u du is the natural log of the absolute value of u. Plus c not needed, because we're integrating from a number to a number. We don't use plus c in those cases. So we have 1/2 the natural log of the absolute value of 2x minus 3. That's what u equals, 2x minus 3. Integration is from 2 to 5. Tells me to replace any x with 5. 1/2 the natural log of 2 times 5 minus 3. 2 times 5 minus 3. That's 7. Minus 1/2 the natural log of the absolute value of 2 times 2 minus 3. 2 times 2 minus 3. That's 1. Natural log of, well, the absolute value of 1 is 1, and the natural log of 1 is 0. So we have 1/2 the natural log of 7. And the absolute value around 7 is not necessary. This would be an answer. You could also write that as the natural log of 7 raised to the 1/2, the log property. Or the answer could be written as the natural log of the square root of 7. Correct answer, correct answer, correct answer. I look at the answer key and it tells me the answer is 0.973. That's the end of this video.